Welcome. This video demonstrates and explains the basic use of the U2V VJC Bldr, a Unity Pro companion tool. The demonstration will show how to create Unity Pro variables to be used with the Bldr for the purpose of automatically generating variables, alarms, and trends into a Vijeo Citect project. I begin by creating a new Unity project. I will use a premium for this demo. The first thing I will do is to configure the project settings to my general preferences. These include enabling the creation of data blocks while online, virtual connected mode, this one is a must, and of course, Unity, please optimize my code. I want the STU file auto-saved. When using Vijeo Citect and the OFSOPC Driver, which I will be and is highly recommended, the data dictionary is also a must-have. Optimized data? Yes. I will be demonstrating application diagnostics, and I always include global diagnostics. Options related to array variables? Another yes. Multi-assignment? This comes in handy. Jump and label and structured text? Can't live without this one. Note that project setting preferences can be exported for subsequent import into other projects. Now I will configure the premium hardware. I will add a combination discrete module and an analog input module. On the combo discrete module, I will assign a variable named myDI to the first input channel, and I will assign a variable named myDO to the first output channel. On the analog input module, I will assign a variable named myAI to the first channel. In the Unity Data Editor, here are the created variables. Now I will create some logic that will use these variables. To include the demonstration of application diagnostics, I will monitor the state of my DI using an alarm diag block, which will inject state changes of my DI into the premium controller's diagnostic buffer. I will rename this instance of the alarm diag block and assign the comment to be my DI is on, which will be the message injected into the premium controller's diagnostic buffer. Now I will scale my AI using a scaling block. I need to convert the data type of my AI from an int to a real, provide a scaling parameters variable, and I will pass the scaled value into a variable named myAIScaled. Next, I will define the scaling parameters. So the default range of 0 to 10,000 of the premium analog input channel is scaled to 0 to 500. I am importing a section containing simulation logic. This section contains a DFB that generates a sine wave. The output of the sine wave generator will be written to the analog input channel by way of the variable myAI. Also in the simulation section, the state of my DO is written to my DI. This will act as if I have physically wired the output channel to the input channel. This completes the logic to be demonstrated. Now it is time for me to define the variables in Unity that will be used in Vijeo Citect. This definition also includes how the variables will be used, or stated differently, which variables are alarm and/or trend variables. Here is the syntax that is used in the custom field of the Unity data editor. The custom field can be displayed in the data editor by right-clicking in the data editor and using the Customize Columns feature, and/or the custom field is visible in the Data Properties window. You can pause the video here to review the syntax. Here I apply the U2V definitions. My DO is an output that I will control from Vijeo Citect, so it will have the VJC syntax. My DI is an alarm, so it has the VJA syntax with alarm category 1, alarming on a 1 state, and residing in area 1 of my system. The comment, my DI alarm, will appear as the alarm message in Vijeo Citect. My AI scaled will be trended in Vijeo Citect. It has the range of 0 to 500, and I will assign the engineering units to be GPM, and it too resides in area 1 of my system. To complete the definitions, I am including comments for the Vijeo Citect variables. These will become comments for the Vijeo Citect variable and trend tags. I build and save the application, then export it to a ZEF format. Now it is time to create the Vijeo Citect application. I will create a new project based on the tab style and using the starter project. There is one thing that must be done first: to create a user. The Vijeo Citect driver that will be used is the OFSOPC driver. So the first thing I need to do is configure the OFS server. I will assign the PLC name, the IP address of the loopback, so we will use the Unity simulator for this, and use the data dictionary of the Unity PLC. I will save the configuration changes and save an archive file of the OFS configuration. The archive file will be used by the U2V VJC Bldr tool. Next, I will open the U2V VJC Bldr tool and use the utility, the OFSOPC Server Builder, to generate the Vijeo Citect servers. This is where I use the OFS archive file, and I select the Vijeo Citect project, enter a cluster name, the IP address of my computer, and generate the servers. Next, I use the Builder tool to generate the Vijeo Citect variables, alarms, and trends. I select my exported Unity Pro project, and then my Vijeo Citect project. And then I select the PLC from the Vijeo Citect server database, which was created by the OFS archive file. I will assign my alarm area descriptor. And then I process the tags. This reads the exported Unity project, extracting the U2V syntax identified variables. Currently displayed in the Builder is the list of variables that exist in the Unity project. The Builder discovers the new variables to be created in Vijeo Citect. A list is provided which can be copied to the clipboard if desired. When processing of the tags is complete, the discovered alarm and trend updates are presented for review. New tags are highlighted in green, and if there are tag field modifications, these will be highlighted in yellow. These modifications are acceptable, so I generate tags. With tag generation complete, I can now update the Vijeo Citect project. Now I can create a page in Vijeo Citect to interface with the Unity Pro project. I will change the background color of the page. I will add a button to toggle the state of the Unity variable myDO. I will add an indicator to show the state of the Unity variable myDI. I will add static text to identify a value that will be displayed. And I will add that value, the value of the Unity variable myAI scaled. Now I save the page. I will return to Unity, download the project to the simulator, and put it into the run mode. Here you can see that the sine wave generator is feeding values into myAI, and the scaling is functioning. I now return to Vijeo Citect to pack and compile the project. Then I will run through the computer setup wizard, as this was a new Vijeo Citect project. Now I can run the Vijeo Citect project. I am logging into the security system of Vijeo Citect. And here is my demo page. I will first toggle myDO. You can see that the indicator for myDI changes state and that the alarm for myDI becomes active. Bouncing back into Unity, you can see that the diagnostic viewer has been automatically displayed, and it shows the event captured by the alarm diag block that is monitoring the state of myDI. When I toggle myDO again, the indicator goes off and the alarm changes to a non-active alarm font, with the alarm information showing that the state is off. So when I acknowledge the alarm, it disappears. And back in Unity, the diagnostic viewer event is also cleared. Note the disappearance timestamp. Now let's take a quick look at the trended value, myAI scaled. I will open a pop-up of the Process Analyst. Then acquire a list of the available trends, select the trend for My AI Scaled, and add it to the Process Analyst. Here you can see the graph of the sine wave that has been captured in the trend file. Finally, a quick wrap-up. I started with a new Unity project, created variables and code. I defined the variables to be included in Vijeo Citect and how these variables are to be used in Vijeo Citect. I exported the Unity project for use with the Bldr tool. The tool generated the Vijeo Citect servers, variables, alarms, and trends. Then I created a page for visualization and control of the Unity variables. I put the system into operation and confirmed the functionality. There were 4 steps to enable and execute the automated generation, and the result, 0 errors or tweaking to achieve the expected functionality of the system. Thank you for taking your time to watch this. I hope you found it enlightening, and I hope you see how U2V can help you make the most of your energy. Subscribe to this channel to see more demonstrations of Unity Pro tools, tips, and tricks.